everyone, and we're going to continue with quadratic equation. And today we're going to learn how to form new quadratic equation given its certain roots of the equation. So in here we're going to call the quadratic equation as Q for our short form, and the ones that we're going to be using will be alpha and beta. So we're going to learn how to form quadratic equation in this lesson today. Alright, so what is the main or general equation to form a quadratic equation? So the formula will look like x squared minus SORx plus POR equals to 0. And what exactly is SOR? SOR will be the sum of roots. In this case, it will be alpha plus beta. And POR will be the product of roots, and in this case it is alpha times beta. So take note of all the short forms and the terms that we're going to be using throughout the lesson. So assuming now we have a question here and we would like to create a quadratic equation with roots given as 3 and 5. It doesn't matter which one we take as the alpha. We can take the alpha as 3, and we can take the beta as 5. So your sum of roots here will be 3 plus 5 and equals to 8. And your product of roots will be 3 times 5, which is equals to 18. And therefore, remember back our quadratic equation. So that will be x squared, and don't forget it's a minus of SORx plus POR equals to 15. And there you go, the first one here. So we can try another one. Assuming now you have another root and the alpha is -3, beta is half. So what is your sum of roots? That will be -3 plus half, which is -102. And you will see that I would like to change it into improper fraction for a reason that you will see later. And the product of roots will be equals to -3/2. Okay, and therefore the quadratic equation will be x squared minus, and in this case, don't forget to put a bracket because your sum of roots has a negative in it. And then plus -3/2. So we're going to open up the bracket and simplify whatever that we can see for the positive and negative symbol. If I decide to see the fraction, and I'm just going to multiply every term here with a 2, and there you go. So now you see why I actually changed it to improper fractions to actually simplify a lot of writing here. Okay, now what if we have a different kind of questions? Okay, so given a quadratic equation which is this, so you're supposed to find, alright, new quadratic equation with roots and so on. I'm going to give you a few questions, A, B, and C. So before we start, you actually need to find the POR and the SOR of the original equation. So this is the original equation here. Alright, so we're going to look at the original equation and find the SOR first. So we're going to find the SOR. So the SOR will be actually equals to 5. Alright, and the POR will be equals to 3. Okay, then now my question. So the first question is asking you to find the quadratic equation with roots alpha square and beta square, and not forgetting that this is actually equals to alpha plus beta, and this is equals to alpha beta. So if you want to find the sum of roots for alpha square plus beta square, then you have to recall something that you have learned in algebra expansion, where you actually have learned how to open up this or factorize this expression here, so you're going to use exactly the same one. Therefore, if you can remember, then this is what you'll see, and the sum of roots is actually 19. What about the product of roots? That will be alpha squared times beta squared, and you can have this itself, so it's 3, and therefore it is 9. So the quadratic equation will be x squared minus 19x plus 9 equals to 0. Okay, so we're going to move on to question B. And if you're afraid that you might forget, so you're going to write your SOR again. And your SOR is actually equals to 5. And your POR is 3. So now the new question that I would like to ask you is finding the roots, where the new roots are this and this. So the new SOR will be alpha plus 3 plus beta plus 3. That will be alpha plus beta plus 3 plus 3. And that will be 5 plus 6, which is 11. And your POR will be, that is here. And yeah, you have to be careful because you have to open up this using your algebra expansion rule. But fret not, because you have already learned. If you forgot, then please view back my previous video on algebra expansion. Okay, and in this case here, we're gonna look at it as this here, because we're gonna take out the alpha plus beta. Okay, and then I'm gonna put whatever I have into the equation. And that equals to 27. Therefore, your quadratic equation is x squared minus 11x plus 27 and equals to 0. Okay, now let's do 2 more here. So now you have your new roots, and your new roots is alpha plus beta, 1 over alpha and 1 over beta. So your sum of roots will be this. Now the only difficult thing is probably because it looks in a fraction. So let's just recall back how we actually do addition for fraction, and then you'll remember that it is not that difficult. The same thing you would do for product, and therefore you have this. It's almost similar to what we have seen in the earlier example, because you're gonna end up with a fraction here. So I don't like to see a fraction. I'm just gonna multiply every term with the denominator. In this case, it is 3. Alright, one more last question. And say we want to find a new quadratic equation with the roots of s for alpha and for beta. So the same thing, and this time I'm going to factorize out the alpha and beta from here. So what is alpha plus beta? And that is actually 5. And what is your product of roots POR? That will be for alpha times for beta, which is 16 alpha beta. And 16 multiplied plus 3, it is 48. So what is your sum of roots? And that's product of roots, so minus 20x plus 48 equals to 0. And there you go. This is the second part of the quadratic equation from our previous lesson. We have one more where I'm going to teach you on how to actually find a range given the characteristics of the root. So stay tuned and follow me in my next lesson. Till then, make sure you subscribe to my channel. Bye bye.